Okay, now we get to C3. This is the longest problem, but it's not really very hard. Now, I know some of you freak out because you got to make a triangle, and you got to use that sine, cosine, tangent stuff again, and you freak out, and you're thinking, get over it, figure out how to do a triangle. It's not that hard. We have a 69.3 kilogram boat floating at 14.3 meters per second. So, 69.3 kilogram boat going at 14.3 meters per second. If we multiply those out, this is just the m times the v, so that's the momentum. P equals mv. So 69.3 times 14.3 means we have a total of 991 Newton seconds of momentum before they collide into each other. So that's how much momentum is going straight forward. Well, what happens is, of course, when it hits the little buoy that's floating in the water, it gets sent off 28 degrees to the right. So this is going to go this way, 28 degrees from the boat's original direction. So that means the buoy is going both forward and to the right. Well, the boat, on the other hand, would have to get deflected the other way. So if the buoy goes to the right, the boat goes to the left, which means the boat is going both forward and to the left. So we say, well, what do we do next? Well, I told you how fast the buoy is going, so you can find out the momentum going right here. So we end up with a 28.3 kilogram buoy, got shoved 28 degrees to the right, going 22.4 meters per second. So if we multiply m times v again, we get momentum. And again, the thing you want to remember is the only thing that can go on the triangles are momentum numbers. Don't stick velocities on there, only stick momentum numbers. So when we multiply these out, we end up with 634 Newton seconds is going this way. Well, of course, we have an adjacent side over here and an opposite side over here. And again, we're comparing to the angle. Compared to this angle, this side is adjacent, and the one over here is going to be opposite. To find the opposite side, we are going to use sine. Every time we do opposite, we do sine. So we're going to have the sine of 28 times the hypotenuse of 634. Make sure your calculator is in degrees. So sine 28 times 634 gives me 298 Newton seconds going to the right. Well, before the things collided, we had no momentum going to the right. If we have no momentum going to the right before the collision, then we have no total momentum going to the right after the collision. So if we got 298 going to the right, we also have 298 going to the left, because that way they cancel out and we have no momentum going to the side, only momentum going forward. Now again, if we want to find this little side up here, the little green side, that was the adjacent side, and to do the adjacent side we want to use cosine. So it's going to be the same formula we had just above there, except we're going to use cosine instead of sine. And so we're going to have cosine 28 times 634, and that's going to give me 560 Newton seconds. So this side here is 560. Now, if we had a total going forward before of 991, and now we can only account for 560 of it, we say 991 minus 560 gives me 431 Newton seconds that's missing going forward. So guess what? 431 must mean this part of the triangle, because that way these two together add up to what this was before. So the total forward afterwards still equals the total forward before. See how that works? Easy, right? So now I have a triangle that's over here, and I have the 431 is one side and the 298 is the other side. And how do I find the hypotenuse? Of course, I use Pythagorean's theorem. So we're going to have 431 squared plus 298 squared equals, and then we square root that answer, and we find that this is 524 Newton seconds. Now, that is the momentum. And again, the only thing that was on any of these triangles were momentum numbers. But I didn't ask you for the momentum, I asked you for the speed of the boat. So the speed, again, is P equals mv. If I'm looking for the v, the m needs to come down there. So I'm going to take that 524 and I'm going to divide it by the mass of the boat, which we remember from the beginning was 69.3. So 524 divided by 69.3, and I end up with 7.56, 7.56 meters per second. So this would be the speed of the boat. No problem. Now I need to find the direction of the boat. If I'm looking for the direction of the boat, again, I'm looking for this angle right here. Well, if I'm looking for this angle, the way we always looked for the angle when we're looking at a triangle is we always do tangent to the -1, and on the top we do the opposite, on the bottom we do the adjacent, so it's always O over A. So opposite of this was the 298, and adjacent to this was the 431. So second tangent, 298 divided by 431, and that gives me a whopping 35 degrees to the left. And that's it. Hey, that answers the answer on the back of the sheet. I love it when that happens.